In this video, we're going to be looking for the present value of an annuity, so instead of the future value. So the difference here is when you're looking for a future value, you're making periodic payments into an account. But more importantly, the amount in the account is growing, right? You're gaining more and more money in your account, so every time they apply interest, it's more interest than it was before. In this section, we still are going to be making payments, okay? So it's still an annuity, so you make periodic payments, but maybe it's to pay back a loan, or maybe it's so you can make periodic withdrawals. So instead of making a payment, you're actually taking money from an account. Okay, this is a different type of problem. It's when we look for the present value of an annuity. Before we do that, let's just think about an easier problem. So this is just for compound interest. So if I want to have $1,000 in the future, how much do I need to have right now? Okay, if I'm in a compound interest account. So what we know, okay, so here we want A to be 1,000, okay, and we want to find P. So you know that A is P times 1 plus I to the n. Okay, so that means that P, if I divide by 1 plus I to the n, it's going to be A over 1 plus I to the n. Or we could write that as A times 1 plus I to the negative n. Okay, we're going to be using this and then the same idea that we did in the last video. Let me just fix that in here. Okay, so suppose I want to deposit a large sum right now so that I can withdraw $1,000, okay, every 6 months for the next 2 years. So twice a year for 2 years. So that's 4 times in total. The account pays 6% interest, so my R is 0.06, and it's compounded semi-annually, so again it has to match, so that's twice per year. How much do I need now in order to have enough money to make these withdrawals? Okay, so I want to put in an amount right now so that I can withdraw this other amount every 6 months. So what's going on? I'm going to again draw my little number line here. Okay, so I want to make 4 withdrawals. Okay, so this is the 1 year mark. Okay, this is the 2 year mark. Oops. So I want to withdraw $1,000 each time. So we want to work backwards. Okay, so in order to have this $1,000 one compounding period from now, I want to know what was my P value. Okay, so what did I need to have initially in order to have $1,000 in one period? So I want my A to be 1,000, and I want to find P. Okay, so that means using the formula we have up above, this is going to be 1,000 times 1 plus 0.03 to the minus 1, because it's one compounding period, so n is 1 here. Maybe I should have just said I is going to be R over M, so that's 0.06 over 2, or 0.03. Okay, so that's where that 0.3 came from. So I need this amount of money now. Okay, in order to have the $1,000 after 2 compounding periods, I needed to have in my account 1,000 times 1 plus 0.03 to the minus 2, because it's 2 compounding periods from now. Okay, similarly, for this third one, I needed 1,000 times 1.03 to the negative 3. And for the fourth one, 1,000 times 1.03 to the negative 4. Okay, so the amount we need now, I'm going to call it PV. Okay, it's the present value. It's like the P, is all of these added up. So these are all 1.03. Okay, so I need to have that now. Using the same trick as before, okay, if I multiply by 1.03, then this one is just 1,000. All the powers, because they're negative, they actually increase by 1, but the numbers itself get smaller. So -2, -3. So then if I, again, subtract, okay, 1 minus 2, so I'm going to subtract those. What I'm going to have is I can factor out PV, and I'm just going to have 0.03 left. So it's 1.03 minus 1. And from this side, I'm again going to get a lot of canceling. Okay, so these two are going to cancel, the -2s are going to cancel, the -3s are going to cancel. And what I end up with is 1,000 minus 1,000 times 1.03 to the -4. So if I factor out the 1,000, okay, again, similar to before, I get the 1,000 times 1 minus 1.03 to the -4, okay, over 0.03. So we see that the 1,000 is our sort of payment or removal value. Okay, the 0.03 is our I, so 1.03 is 1 plus I, and the -4, the 4 is our N. Okay, this is following the same form as the other, okay, slightly different. But this is what the formula, the closed form formula, so instead of needing to do a sum, this is what a formula would look like. So if you want to find the present value for an annuity, so suppose we're making periodic payments of PMT into an account with interest rate R, okay, compounded M times per year, in order for the account to reach $0 in T years. So it's like we're paying back a loan. Okay, so this is stated like a loan, but it could be also like a withdrawal. Okay, then the present value, so maybe I'll just write, so this is PV is present value, and it's similar to the P. Okay, so it's like the amount we need now in order to do that. It's going to be our payment, PMT, times 1 minus 1 plus I to the -N all over I. Okay, so that's our formula. Now let's do an example. So I know I can afford $1,000 monthly mortgage payments, and the bank offers me a 15-year mortgage charging 8% interest compounded monthly. What is the maximum amount I can borrow if I want to have it paid off in 15 years? Okay, so here my payment, so the amount I know I can pay is $1,000. The interest rate is 0.08. It's compounded monthly, so my M is 12, and the T is 15 years. Okay, and then so we want PV for this one. We want to know how much can I borrow. So what's the present value of this amount? So if you want, you could start by computing I and N. So I is 0.08 over 12, which is not a nice number, 0.0667, but I rounded here. So it's probably better not to round it, but if you have to, you can. N is going to be 12 times 15, so M times T, which is 180. So then my PV, and I'm not going to round, so I'm going to write it as R over M. So it's going to be 1,000 times 1 minus 1 plus 0.08 over 12 to the power -180 divided by 0.08 over 12. Okay, now if you compute that, you should get $104,640.59. Okay, so this is the maximum we can borrow. So the most confusing part with these annuities is to tell whether you're looking for future value or present value. So I just want to try to illustrate the difference here again. So in a future value, the amount in the account is growing. Okay, so it's like you're saving up for something, but more importantly, the interest being added is increasing. Okay, so each time they add interest, it's more than it was before. Okay, so here you want to think of like a savings account. Okay, so you're saving up for something. The present value, the amount in the account is decreasing. Okay, so each time you take out money or you make a payment, the amount that you owe or the amount that you have left is less than it was before. Okay, so when you add interest, the amount is going down, so the interest is decreasing. The amount of interest they add each time is slightly less. So for these ones, you want to think of loans, okay, or regular withdrawals. Those are the most common. So you either borrow an amount and you're paying it back, or you deposit a large sum and then you want to withdraw from it periodically. But in both cases, you're aiming at the end of the T years to be at $0. Okay, so at the end, you get to $0. Okay, that's the idea.